Hey, I'm going to do number 9. All right. So it's looking at hummingbirds who've been studied by a zoologist. Suppose that a small group of 17 hummingbirds was being studied in Arizona. The average rate of these birds is 3.15 grams. And based on previous studies, we can assume the weights have a normal distribution with a standard deviation of 0.28. All right, that's really important right there because it says based on previous studies and it has a normal distribution. So I'm going to call that a population standard deviation. So that's great because it gave it to me. It wasn't based on that sample, it was based on previous samples. And that's where it's important. If I can get something about a huge population, that holds more weight than my sample in terms of standard deviation. All right. So now it says, when finding the 80% confidence interval, what's the critical value? Well, I went in the book and I got that table. I would either write down that table, take a picture of that table. Remember, the final exam isn't proctored, so that you have this table to look at. So this is 1.28. Okay. All right, so now it wants me to find the 80% confidence interval. All right, so my first step is I've got to find, well, I want to find my lower, my upper, my margin of error. The first thing I'm going to do is find my margin of error. Then I'm going to do it with my calculator, and I'm going to do it in a couple of steps so that it makes it easier. All right, to find my margin of error, I'm going to do it like this. I'm going to do 1.28, which is my critical value, times, and then I'm going to do 2 sets of parentheses. Okay. Up here, again, is going to be my standard deviation, which was 0.28, which is my population standard deviation. I'm going to put my population standard deviation on the top, and I'm going to divide it by the square root of my sample size, which was 17. And I close those parentheses and I close it again and I get 0.8692. And this one only wants 2 decimal places, so we're going to round it up to 0.09. Okay, so that is going to be my margin of error. So now with that, I can find my lower limit. So I'm going to do 3.15, which is my mean. You can see it right here, right there, minus 0.09, which is 0.306. Okay, and let's do my upper. So again, all I'm going to do is do 3.15 plus 0.09, and I get 3.24. Okay, so that's my upper. So my range, or my 80% confidence interval, is 3.06 to 3.24. Okay, what conditions had to be met? So I know that I had a normal distribution because it said here normal distribution. Okay, and I know I had a population standard deviation because it gave it to me right here. So that's everything I had. So the rest of these were not in my problem. Okay, so it wants to know, interpret my results. So my results are, we're 80% confident that the true average weight of these hummingbirds will fall in this interval. Okay, so now it wants to know how to get the sample size when I know my population standard deviation. This actually is the correct formula. This right here should be a C. I don't know why they did it wrong, but we're going to use this formula to get the necessary sample size when my margin of error is 0.14. Do not use this margin of error up here of 0.09. You're going to use this one of 1.4. Okay, so let's do it. I'll clear my calculator. Okay, so my first step is this. Parentheses. I'm going to do 1.28, which again was my critical error, times 0.28, which was my population standard deviation. Close those parentheses, and then I'm going to divide by the margin of error. Okay, I hit enter. But then my last step, you see I have to square it. So I'm going to just hit the square button, and I get 6.5536. Okay, but you always have to round up. You round up for sample because I can't have a sample of 6.5 hummingbirds. I need to go up because there's a decimal there. So this becomes 7. So that's how you do number 9.